Hello students. So in the previous video, we had started with polynomials and we discussed what are variables, what are constants, and different types of polynomials, degree of polynomial, all those stuff. So let's recall all those things, then let's move forward. So what is a variable? It is a symbol whose value is not fixed. Basically the English alphabets. What is a constant? It is a symbol whose value is fixed, like pi or the numbers 1, 2, 3, all these values are fixed. Next, what is an expression? Mathematical expression or algebraic expression? It is simply the combination of variables and constants, or constants with variables, or variables with variables, anything. Okay, that is known as mathematical expression. You combine them using plus sign or minus or into or division. These are known as algebraic expression. So what is a polynomial? It is also an algebraic expression, meaning it is a combination of variables and variables, or variables and constants. It is in such a way that the powers of the variable are always whole numbers. Okay, that is, you won't have negative numbers, you won't have fractions, all those stuff. Okay, so those are known as polynomials. Next, what is the degree of a polynomial? Degree of a polynomial is simply the highest power of the variable involved. That is known as the degree of the polynomial. Based on the degree, we have got couple of types, like linear polynomial whose degree is 1, then quadratic polynomial whose degree is 2, and cubic polynomial whose degree is 3. And based on the number of terms you have got, if you got only one term, we call it as monomial, two terms binomial, three terms trinomial, and so on, we always call it as polynomial, isn't it? Now we also discuss zeros of a polynomial. Let me start from here again. Zeros of a polynomial. What is zeros of a polynomial? We have already discussed in the previous video, but let's recall it again. Zeros of a polynomial is a value. Okay, it is any value, it's a real number. It can be fraction, it can be a negative number, it can be irrational number, rational number, any number. It's a real number. Okay, any real number, you can call it as a zero of a polynomial if, when you substitute that value in place of the variable and the final answer comes out to be 0, then you say that value is 0 for polynomial. For example, let's take a simple linear polynomial. This is a linear polynomial, isn't it? Because the degree is 1. Now I will say minus 5 is 0 of x plus 5. Why? Because if I substitute this value in place of the variable x, what is the final answer that I get? 0. Can I say 3 is 0 of this polynomial? No, because if you substitute 3 in place of x, 3 plus 5 gives you 8, but it doesn't give you 0, isn't it? Therefore, you cannot call 3 as 0 of the polynomial. Let's take another example. X squared minus 9. X squared minus 9. This is a polynomial. What type of polynomial it is? There are two terms, you call it as binomial, or the highest power is 2. Therefore, you can call it as quadratic polynomial. Okay. Now, what are the zeros of this polynomial? 3 can be a 0 of this polynomial, because if you substitute 3 in place of x, 3 square is 9, 9 minus 9 is 0. So you're getting the final answer as 0. Therefore, 3 is 0 of this polynomial. I can also say minus 3 is 0 of this polynomial, because minus 3 in place of x. Minus 3 the whole square is what? Minus 3 whole square is minus 3 into minus 3. Minus into minus plus 3 3s are 9. So minus 3 the whole square is also 9. 9 minus 9 gives you what? 0. So when you substitute 3 also, you are getting the final answer 0. When you have substituted minus 3 also, you are getting the answer as 0. Therefore, what are the zeros of this polynomial? 3 and minus 3. Now, if you observe carefully, based on the degree, here the degree is 1. So you will get only 1 0 of a polynomial. Here the degree is 2. Therefore, you get 2 zeros of the polynomial. Okay. So basically, what are zeros of the polynomial? Those are values, any kind of values. When you substitute in the place of variable, the final answer comes out to be 0. Okay. And we are going to discuss only about quadratic polynomials in this chapter. What are quadratic polynomials? polynomial whose degree is 2 is said to be quadratic polynomial. And what is the general form? The general form is ax squared plus bx plus c. This is the general form of quadratic polynomial. And if you equate it to 0, it becomes quadratic equation. If you equate it to 0, now it is just an expression. If you equate it to something, it becomes equation. Now it is a quadratic expression or quadratic polynomial. If you equate to something, it becomes quadratic equation. Okay. So let's start with quadratic polynomial. So we know what is a quadratic polynomial. The very important concept in this chapter is relationship between the zeros and the coefficients of quadratic polynomial. That is, let's take ax square plus bx plus c. What is this? This is the general form of quadratic polynomial. Here a is the coefficient of x square, b is the coefficient of x, and c is the constant term. Okay. Suppose, let's say alpha and beta are the zeros of the polynomial of the quadratic polynomial ax square plus bx plus c. Isn't it? It's a quadratic polynomial, meaning the degree is 2. If the degree is 2, we'll get 2 zeros. I'm taking those 2 zeros as alpha and beta. You can take any other name also, but in general, we take it as alpha and beta. Okay. There is a relationship between this alpha, beta, and the coefficients a, b, c. Okay. That is sum of the first one, sum of zeros. Sum of zeros. That is, let me write it, sum of zeros, that is alpha plus beta, that will be equal to minus b by a. Okay. So this is one relation, that is alpha plus beta will be equal to minus b by a, and product of zeros alpha into beta will be equal to c by a. Very, very important formulas which we are going to use in many places. Okay. And the first exercise is actually based on this. So the sum of zeros, alpha plus beta, if you have got two zeros, definitely we'll have two zeros for quadratic polynomial. If you add those two, it will be equal to minus b by a. What is b? Coefficient of x. And what is a? Coefficient of x square. You can also write this as minus, what is b? Coefficient of x, that is the power 1. X power is what? 1 divided by coefficient of the power 2, that is x square. Okay. And this also you can write it as the constant term, that is 1 without any variable in it. Has this got any variable with it? No. So constant term divided by what is a? Coefficient of x squared. Usually we don't write these two things. We always write this alpha plus beta is minus b by a, alpha into beta is c by a. Now these are the formulas, but let's understand how did we get these formulas. Okay. Let me erase this. So let's understand how we got the formulas. Okay. The derivation is actually not required, but let's understand. Okay. Now, if you remember, if any number, if alpha is 0 of a polynomial p of x is a polynomial, the meaning is it is a polynomial in variable y. The variables will be x. If I write p of y, then it means polynomial in variable y. Okay. So if alpha is a 0 of a polynomial, then x minus alpha is a factor. You would have learned it in your 9th standard. Definitely. Isn't it? If alpha is a 0 of a polynomial, then x minus alpha, that number will be a factor of it. Okay. I'll give you a simple example. Okay. Let's say let's take x square minus 9. Okay. 3 is 0 of this polynomial, isn't it? If you substitute 3 in place of x, 3 square is 9, 9 minus 9 is 0. You're getting the final answer as 0, isn't it? Therefore, I can tell 3 is 0 of this polynomial. Now, if 3 is 0 of the polynomial, then x minus 3 is a factor x square minus 9. Meaning you can divide this by this. But it's very simple. X square minus 9. Observe, this 9 can be written as 3 square, isn't it? So it is in the form of a square minus b square. What is a square minus b square? A minus b, a plus b. Observe, this can be written like this. Can't I divide by x minus 3? Definitely we can divide it. What will be the remainder? What will be the answer? X plus 3 will be the answer, isn't it? So that is what I said. If any number is 0 of a polynomial, then x minus that number will be a factor. Okay. Similarly, for this polynomial, we also said minus 3 is a factor, isn't it? Sorry, minus 3 is a 0. Minus 3 is 0 of the polynomial. If minus 3 is 0 of the polynomial, then x minus that number. So x minus of minus 3 is x plus 3 is a factor. See, again we have got it here. Easily I can divide it x plus 3, isn't it? So using this, we can understand the derivation. Okay. So for the quadratic polynomial, you will have two zeros, isn't it? So alpha and beta are what? Zeros of quadratic polynomial, isn't it? Ax square plus bx plus c. Meaning then x minus that number and x minus beta, x minus this are what? Factors. Are factors of p of x. That is polynomial ax square plus bx plus c. Okay. Now this can have only two factors, isn't it? It cannot have more than that because the degree itself is 2. Okay. Therefore, it means ax square plus bx plus c can be written as product of these two things, x minus alpha into x minus beta. To make it very, very simple, if you remember in your previous year or in the quadratic equations which we have already done, x square plus 5x plus 6. If you remember, we will factorize this and write it like this, isn't it? At the end, x square plus 5x plus 6 can be written as x plus 3 into x plus 2. That is what we have done. Ax square plus bx plus c can be written as x minus alpha into x minus beta. Okay, because alpha and beta are zeros. That's what we have taken. Okay. Now, let's multiply this. Okay. So x into x, x square, x into minus beta x, minus alpha into x, minus alpha x, minus into minus, plus alpha into beta, alpha beta. Okay. Now, x square, if you observe both the place x is there, I can take x as common. I'll take minus x as common. So if I take minus x as common, what is left out? Alpha plus beta or beta plus alpha. I've just changed it. Okay. Let me rewrite this. X square minus alpha plus beta into x plus alpha beta. Isn't it? Here what you have got in the... Okay. Here if you observe, the coefficient of x square is 1. So I'll make the coefficient of x square as 1 here. How will I make it? Just divide by a. Okay. So if I divide by a and a gets cancelled, the coefficient of 1 is same. Okay. Now if you compare, both are equal, isn't it? So let's compare. So the coefficient of x square is 1. The coefficient of x square is 1. No problem. Now let's compare. What is the coefficient of x? The coefficient of x here is minus alpha plus beta, isn't it? With the sign. What is the coefficient of x here? B by a. Let's transpose this minus to the other side. So that is how we got the formula alpha plus beta equal to minus b by a. Now comparing the constant term. What is the constant term here? C by a. What is the constant term here? Alpha into beta. Therefore, alpha into beta equal to C by a. Okay. The derivation is not required. We just did it so that we'll understand how we got this. Okay. So the sum of zeros, that is alpha plus beta, is minus b by a, and the product of zeros, alpha into beta, is C by a. Now let's solve problems based on the relationships. Okay, students, let's start with the exercise 2.2. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. First, we have to find the zeros of the polynomial. Then we have to verify the relationship, that is alpha plus beta equals minus b by a, whether it is satisfied or not, and alpha into beta is equal to c by a. Okay, so let's start this. So the first question is x square minus 2x minus 8. Okay, the first question in the exercise 2.2, x square minus 2x minus 8. Okay, first we have to find the zeros. What are we trying to do? Zeros means we are trying to find a value which, when substituted in the place of x, should give you the final answer as 0. Okay, so for that, the first step will be, let's take this polynomial and equate it to 0, because the final answer that we are expecting is 0, right? So that's why we are equating it to 0. The next step is finding the value of a, b, and c. What is this a, b, and c? A is the coefficient of x square, b is the coefficient of x, and c is the constant term. So what is the value of a here? 1. X square coefficient is 1. And what is the value of b here? It is minus 2. Why is it minus 2? Actually, the standard form of quadratic polynomial is ax square plus bx plus c, isn't it? If you get it in the standard form, x square, you got minus 2x, but I can write this as plus of minus 2x and plus of minus 8, isn't it? So therefore, if you compare now, b value is what? Negative 2. This is the standard form. All the terms, in between the terms, you got plus sign. So if you make it like that, on equating it, b value is minus 2 and c value is minus 8. Okay, so but in general, what we do is, we will take the coefficient of x with the sign. Okay, here the constant term with the sign is minus 8. Now what we have to do is multiply this a and c. Basically what we are doing is factorization method, okay, or splitting the middle term. So a into c. What is a into c? 1 into minus 8. So we get minus 8. Now we have to find the factors of minus 8, meaning we have to find two numbers which when multiplied should give you minus 8. And since you got minus here, we have to subtract those two numbers in order to get minus 2. Okay, I'll repeat it. We have to find two numbers, that is any two numbers. If you multiply, you should get minus 8. And if you subtract, then why subtraction? Because you have got a negative sign here. Okay, based on this, we decide whether it is addition or subtraction. Here it is minus, so we are going to subtract. If it is plus, we will add it. Okay, here you got minus, so if you minus it, you should get minus 2. Okay, so the numbers will be 4 2s, isn't it? 4 2s are 8. If you multiply, you're getting 8. 4 minus 2 gives you 2. Okay, actually we need minus 2, therefore it will become minus 4 plus 2, because minus 4 plus 2 will give you minus 2. If you do the other way, plus 4 and minus 2, it gives you positive 2, but we need is negative 2, isn't it? Therefore minus 4 plus 2. So minus 4 into plus 2 is minus 8. Minus 4 plus 2 is minus 2. So we have got the numbers. The first term as it is, 1x square as it is. Instead of the middle term, let's introduce these two numbers, minus 4 with x, okay, because it is minus 2x. We are concentrating only on the numbers. So let's also introduce the variable, minus 4x plus 2x. The last term as it is. It's like we have split this middle term into two parts. That is why we call this as splitting the middle term. Okay, so the first and the last remains as it is. The middle term is split into minus 4x plus 2x. If you operate it, combine it, what do you get? You get back minus 2x, isn't it? So now the next step is take common between these two things, common between these two things. Now how to take common? Very simple. Now concentrate on the numbers. Here you got 1, here you got 4. Which is the highest number that divides 1 and 4? It is 1. So 1 will be common. Between x square and x, in the variables, it is always the least power that you have to take common. Between x square and x, it is x that is common. Okay. Now you have taken 1x as common. So what should you write here? X. Because 1x into x gives you 1x square, isn't it? Minus You have already taken this x outside. So what is left out? 4. Or you can say it like this, 1x into 4 gives you 4x. Okay. Now whatever sign you have got here, same thing as it is. Now between 2 and 8, what is common? Which is the highest number that divides 2 and 8? It is 2. I have taken 2 as common. What is left out? X minus, you should not write here 8. Okay. 2 into what gives you 8? Last time 1 into what gives you 4? 1 into 4. This time 2 into what gives you 8? 2 into 4 gives us 8. If you have done this correctly, in this bracket and in this bracket, you get the same binomial. Okay. X minus 4, X minus 4. Again, let's take X minus 4 as common. Here I have taken, from both the things, I have taken X minus 4 as common. So what is left out? 1x here plus 2 equal to 0. Remember one thing, you are multiplying two numbers and you are getting the answer as 0. Then any one number out of these two should be 0, or both can also be 0. So which implies either A is 0 or B is 0. So now this expression is like, this entire thing is like A and this entire thing is like B. Okay. So you're multiplying two numbers A into B, you're getting the answer as 0, which implies A is 0 or B is 0, isn't it? Therefore, x minus 4 should be equal to 0 or x plus 2 should be equal to 0. A is 0 or B is 0. So x will be equal to minus 4 to the other side will become plus 4. It is actually 0 plus 4. 0 plus 4 is what? 4. So directly we neglect this 0 and directly minus 4 to the other side will become plus 4. Similarly, x plus 2 plus 2 to the other side will become minus 2. Therefore, what are the zeros of the polynomial? The zeros of the polynomial are 4 and minus 2. You can check it. If you substitute 4 in the place of x, the final answer will be 0. Similarly, if you substitute minus 2 in the place of x, the final answer will be 0. Okay. Now let's verify the relationship. What is the relationship that we have to verify? The first thing that we have to verify is whether alpha plus beta is equal to minus b by a. We have to verify this. So let's find the LHS separately, RHS separately. Alpha plus beta first. Okay, what is alpha? This is our alpha. Okay, you can take 4 as your alpha. 4 as our alpha. So alpha is how much? 4 and beta is minus 2. So 4 plus into minus is minus 2. 4 minus 2 is 2. So alpha plus beta is 2. Okay. Now what is minus b by a? Minus, what is b value? Minus 2. A value is 1. So minus into minus plus 2 by 1 is what? 2. You got the same answer. Alpha plus beta is also 2. Minus b by a is also 2. Therefore, you can tell alpha plus beta is minus b by a. Verified. Second one is, you have to find whether alpha by beta is equal to c by a. Let's take it out. First, let's find alpha into beta. Alpha is 4, beta is minus 2. Therefore, you get minus 8. C by a. C is minus 8, a is 1. So minus 8 by 1 is minus 8. Both the answers are same. Therefore, alpha into beta should be equal to c by a. So here what we have done is, we have found the zeros and we have verified the relationship. Similarly, let's do the next problem. So second question, it is 4s square minus 4s plus 1. Now what is this? It is a polynomial in variable s. So we write it as p of s. Okay. The first question was p of x. The second question is p of s. That's it. You can also take it as x, no problem. The question is 4s square minus 4s plus 1. So let's solve this. The second question, 4s square minus 4s plus 1. What will be the first step? The first step is to equate it to 0. Take the polynomial and equate it to 0. The next step is find a, b, c. Okay. So here a is 4, b is minus 4, c is 1. So let's multiply a and c. 4 into 1, we get it as positive 4. Again, we have to find two numbers in such a way that if you multiply, you should get positive 4. And if you add them, here it is plus sign. So if you add them, we have to get minus 4. Or first, let's not consider the negative sign. Let's focus on the number. It is 4, right? So if you multiply, you should get 4. If you add them, you should get 4. So the number is 2 2s are, isn't it? So 2 2s are 4. 2 2s are 4. 2 plus 2 is also 4. But you have to get negative 4. So therefore, it should be minus 2 and minus 2. Observe, minus into minus plus, 2 2s are 4. Minus 2 gives you minus 4. So the first term as it is, instead of the middle term, we have to introduce these two things. Minus 2s, both the things. The last constant term plus 1 as it is. Between the first two, we have to take common. Between the next two, we have to take common. So what is common? Here you got 4, here you got 2. Which is the highest number that divides 4 and 2? It is 2, isn't it? Between s square and s, we have to take s as common. Now what is left out? Earlier we had 4. We have taken 2 as common. So 2 into what gives you 4? 2 into 2. Observe, 2 into 2 gives you 4. S into s will give you s square. Okay. Minus, observe, we have taken this 2 out, s out. So all the things have come out. So what is left out? 1. Okay. If you multiply, you have to get back the same thing. 2s into 1 is 2s. Okay. Now whatever sign is there, minus as it is. Between 2 and 1, which is the highest number that divides both? It is 1. Okay. So 1 into what gives you 2s? 1 into 2s itself. So whenever you take 1 as common, the same things as it is. But where the minus is outside, therefore this sign changes. This will become minus. Plus will become minus. If it was minus, we would have written it as plus. Okay. 1. Whenever you take 1 as common, the same thing. But minus is outside, therefore you have to change the sign. Observe, now you got the same thing, 2s minus 1, 2s minus 1. The left out things, 2s minus 1 equal to 0. So if a into b is equal to 0, implies a is equal to 0 or b is equal to 0. Therefore 2s will be equal to 1, or same thing, 2s will be equal to 1. Therefore s will become 1 by 2, or here also s will become 1 by 2. Here alpha and beta both are same. Alpha and beta both are same. Okay. That is alpha, beta both are equal to 1 by 2. First, let's verify the relationship alpha plus beta, whether it is equal to minus b by a or not. So what is alpha plus beta? 1 by 2 plus 1 by 2, which comes out to be 1. What is minus b by a? Minus b is 4, a is 1. Okay, this is minus of minus. So it becomes 4 by 4, which is 1. Both are same answers. Therefore, alpha plus beta should be equal to minus b by a. Now let's check the second one. Alpha into beta is equal to c by a. Alpha is 1 by 2. Beta is also 1 by 2. So 1 by 2 into 1 by 2 is 1 by 4. What is c by a? C is 1. A is 4. So c by a is also 1 by 4, isn't it? Therefore, alpha into beta is equal to c by a. Okay. Similarly, let's do the third problem. Okay, third question, 6x square minus 3 minus 7x. Okay, 6x square minus 3 minus 7x. Now, basically, first of all, this is not in the standard form. That is, what is the standard form? Ax square plus bx plus c. That is, it is in the decreasing orders of the powers. Here you got highest power as 2. Next, highest power 1. 7x should come. Then 3, isn't it? So let's rearrange this first. 6x square minus 7x minus 3. Okay. After rearranging, let's equate it to 0. See, minus 7x comes first, then minus 3. Okay. We have rearranged it and we have equated to 0. The same stuff, a, b, c. What is a here? 6. B is minus 7. C is minus 3. So a into c, that is 6 into minus 3, that gives you minus 18. So again, if you multiply, you should get 18. Since it is minus, you have to subtract it to get 7. I repeat it. If you multiply, you should get 18. If you subtract it, you should get 7. Therefore, the numbers are 9 and 2. 9 2s are 18. 9 and 2, if you subtract it, you get 7. You should get minus 7. Therefore, minus 9 plus 2. Okay. Minus 9 plus 2 will give you minus 7. Okay. 6x square as it is. Instead of this middle one, we have to introduce these two things. Minus 9x plus 2x minus 3 equal to 0. Now, between these two things we have to take common. Between these two things we have to take common. Between 6 and 9, which is the highest number that divides 6 and 9? It is 3. Between x square and x, it is x. So what should we write inside the bracket? 3 into what gives you 6? 3 2s, isn't it? X into what gives you x square? It is x. So multiply and check it. 3 2s are 6. X into x, x square. Minus this x has already come out. So 3 into what gives you 9? 3 3s are. So you get 2x minus 3. Okay. 2 and 3. What is the common factor between 2 and 3? It is 1. Okay. Whenever you take 1 as common, you retain the same thing. 2x minus 3. Okay. But you have to be very careful. If you got minus outside here, you have to change the sign. Now it is plus, therefore you need not change the sign. You got the same thing, 2x minus 3, 2x minus 3, 2x minus 3 into the left out thing, 3x plus 1 equal to 0. Product of two things is 0, implies either 2x minus 3 should be equal to 0 or 3x plus 1 should be equal to 0. Minus 3 to the other side will become plus 3, therefore x is 3 by 2. Or plus 1 to the other side will become minus 1, or x is minus 1 by 3. Okay. So let's take alpha as 3 by 2, beta as minus 1 by 3. Now we have to verify the relationship. So let's verify that. The first one is alpha plus beta is equal to minus b by a. Consider alpha plus beta. Alpha is 3 by 2 plus beta is minus 1 by 3. Isn't it? Take LCM. The LCM is 6. Okay. So if you take LCM and solve it, it will become 9 plus of minus 2. Okay. So it will become 7 by 6. 9 minus 2 is 7 by 6. Alpha plus beta is 7 by 6. What is minus b by a? Minus b is minus 7. A is 6. So it will become 7 by 6. So you have got the same thing. Similarly, alpha into beta. Alpha into beta is c by a. Alpha into beta is equal to c by a. That's what we have to verify. Alpha into beta, 3 by 2 into minus 1 by 3, which becomes minus 3 by 6, which is minus 1 by 2. Or you can keep it as minus 3 by 6 itself. What is c by a? Minus 3 by 6. Both are same. Alpha into beta is equal to c by a. Let's do the fourth question. So let's get into the fourth question. 4u square plus 8u. This is a polynomial in u, variable u. Okay. 4u square plus 8u. Okay. So 4u square plus 8u. Okay. The first step is equate the polynomial to 0. Remember, we don't solve this by splitting the middle term. Splitting the middle term is for trinomial, 3 terms. Okay, but here you got only 2 terms. Whenever you got 2 terms, directly you can take common. So in general, when you have got even number of terms, you can directly take common. Okay, so that is what we do actually in splitting the middle term. If you observe in the previous question, we had like this, right? What did we do? It was a trinomial. Okay, it was a trinomial. It had 3 terms. We made it as 4 terms. That is, we split the middle term into 2 parts. That is, we wrote it as minus 2x plus 2x, isn't it? Therefore, we have got even number of terms. Whenever we have got even number of terms, directly we can take common. So here we have got even number of terms. That is, there are 2 terms. 2 is what? Even, right? So whenever we have got even number of terms, we can directly take common. Let's splitting the middle term is not required. So if I directly take common, 4u will be common. Between 4 and 8, it is 4. Between u square and u, it is u. What is left out? 2u, sorry, 1u plus 2 equal to 0. Again, the same thing. Product of two things is 0, implies 4u is equal to 0 or u plus 2 is equal to 0, which implies u is 0 by 4 or u is minus 2. 0 by 4 is 0 itself, or u is minus 2. So let's take this as alpha and let's take this as beta. Now alpha plus beta is equal to minus b by a, isn't it? So alpha plus beta, alpha is 0, beta is minus 2. 0 plus minus 2 is minus 2. Alpha plus beta is minus 2. Now let's find minus b by a. Minus b value is coefficient of u, 8. A value is coefficient of u square, 4. So 4 ones are 4 twos are. We got the same answer. Therefore, alpha plus beta is equal to minus b by a. That is correct. Next thing is alpha into beta is c by a. Now let's find alpha into beta first. Alpha into beta, alpha is 0, beta is minus 2. 0 into minus 2 is 0. Now c by a. Do we have any constant term here? No, there is no constant term. If there is no constant term, we take c as 0. A is 4. 0 by 4 is 0. We got the same answer. Okay. So whenever we have got even number of terms, directly we can take common and you can find the value of the variable. Here it is u, so we found the value of u. If it is x, we'll find the value of x. Okay. Similarly, let's get into the next question. So the fifth question and sixth question are similar to the problems which you have solved. So you can take it as a task and you can try it out. Okay. Now we'll get into the second main. Find a quadratic polynomial. Okay. Observe the difference. The first question was they had given us the quadratic polynomial. We had to find the zeros. Here, find a quadratic polynomial. We have to find the quadratic polynomial. It is given that each with given numbers as the sum and product of its zeros respectively, meaning they have given the sum of zeros and product of zeros. That is, they have given the alpha plus beta value and alpha into beta value. Using this, we have to find the polynomial, quadratic polynomial. So let's do that. Okay. How to find the polynomial? If alpha and beta are the zeros of the quadratic polynomial, that is ax square plus bx plus c, then you can find the polynomial. If alpha and beta are the zeros of the quadratic polynomial, let's write it like this: of the quadratic polynomial, then the polynomial is given by x square minus alpha plus beta into x plus alpha into beta. Okay, this is the formula that we are going to use. Okay, when the zeros are given, we have to use this formula to find the polynomial itself. Okay, so let's take the first question. The first question is 1 by 4 and minus 1. Okay, let's look into the question again. Let's confirm whether it is 1 by 4. Yeah, it is 1 by 4 and minus 1. So the question says each number is, this number is sum of zeros. That is alpha plus beta is 1 by 4 and the other number is alpha into beta. Okay, sometimes they might change the question. Here the question is we have to find the quadratic polynomial. They have given us the sum of zeros and the product of zeros. They have already given this. This is what? Alpha plus beta, and this is alpha into beta. They have given it. Okay, sometimes they might give you only alpha and beta. If the zeros are, for example, if the zeros are 3 and minus 2, find the quadratic polynomial. Do not consider this as alpha plus beta. Okay, because the question is only the zeros. Here in the question, they have clearly mentioned that it is sum of zeros. So alpha plus beta is 1 by 4, alpha into beta is minus 1. So if you substitute in the formula, easily you will get it. So x square minus what is alpha plus beta? 1 by 4 x plus what is alpha into beta? Minus 1. So if you simplify this, x square minus 1 by 4x plus into minus is minus 1. So this is the quadratic polynomial. Okay, so easily you can do the rest of the problems. It's very, very easy. So the first number is alpha plus beta, substitute here. In the next question, if you observe, the numbers are root 2 and 1. So what is the formula? X square minus alpha plus beta into x plus alpha into beta. So x square minus alpha plus beta is root 2. Substitute here. And what is alpha beta? 1. Substitute. That's it. So this is our quadratic polynomial. This exercise is very, very easy. You can complete the remaining problems on your own. Okay. I hope you guys have understood so much. In the next video, we'll start with the next concept, that is division algorithm of polynomials. Thank you, students.